Today we are going to begin our exploration of the different market structures of how businesses compete with and against each other, and we'll begin by discussing the market structure of perfect competition. You will notice there are a range of market structures through the next several chapters, ranging from those market structures which are the most competitive to the market structures which are the least competitive. And each of these four market structures have certain criteria for which to identify which businesses belong in these market structures. So today we're going to discuss perfect competition. This is the market structure with the absolute theoretical most competition that's absolutely possible. On the opposite side of the extreme, a monopoly, by definition, is actually a market structure with no competition. And then there's several market structures in between, and we will discuss those in later chapters. So in looking at these four different market structures, understand that each one of these market structures has criteria for what identifies the firms in those market structures. However, the reality is there is a little bit of blending between one structure to another structure. So while the criteria seem fairly straightforward, in the real world, you might have a little bit of flexibility in terms of classifying whether this business is operating in monopolistic competition, or whether it's operating in an oligopoly, or whether it's operating in a monopoly. It actually may depend on several other factors, but we're going to kind of keep things simple and just look at the criteria for these market structures. So we're going to begin by looking at perfect competition. So in perfect competition, you need to have a large number of buyers and sellers. There's no magic number that indicates how many different firms you need to have this market structure, but you need to have enough of them such that nobody really controls the market. Each of the sellers needs to sell an identical product. Everybody is selling the exact same thing. That's a key characteristic of what makes perfect competition, is that you have a large number of buyers and sellers. They're selling exactly the same thing. And there cannot be any barriers to entry or exit. If a firm wants to begin operating this type of business, they're perfectly free to do that. And if they want to leave the business, they're perfectly able to do that also. A good illustration of markets that are perfectly competitive actually come from the agriculture sector. So for example, corn. If you think about it, if you're a farmer, you know that corn really isn't corn, but in a way it kind of is. If you look at all the fields of corn that are around us, you really can't tell a whole lot of difference between one farmer's corn and another farmer's corn. And in reality, it all gets harvested and thrown in the same bin anyway, and it's a pretty identical product. I used to drive through the fields and I'd see these signs with numbers marking the different rows, and I'd look at these numbers on these signs that marked the different rows of corn, and I wondered what were the numbers? Are they different kinds of corn? But when I looked at it, to me they looked like corn. And so it's a good example of something that's pretty much a perfectly competitive market. A lot of agricultural products are pretty much a perfectly competitive market. There are no single farmers out there that control the world price of corn. The key is, in perfect competition, if you exist in this type of market structure, every firm is a price taker. What that means is they take the price from the market system. They have no control over the price. They just simply have to take the price as it is and do the best they can. Nobody is big enough to really control the prices. And if you think about it, when was the last time you ever saw a billboard that said, buy Farmer Bob's corn, it's better. Or buy Farmer Susie's corn, it tastes good. Corn is corn. There are different varieties of corn, and there are different varieties of lots of agricultural products, but in essence, they're the same. So remember from the previous chapter, the goal of all businesses is to maximize profits. The goal is to maximize profits. It's not to make money, it's to make as much profit as they possibly can. So imagine that you are in an ice cube company. You sell ice cubes. It's probably a good example of an identical market. I mean, it's an ice cube. You buy it in the bags, 5-pound bag of ice. It's a bag. I know that some firms advertise that their ice is healthier. I'm not sure that I could actually identify what makes a healthy ice cube, but imagine you're in an ice cube firm and your bags sell for $1 per bag. Now that's determined from the market system. Supply and demand have the equilibrium price is $1. So really your question is, what output do you sell? How much do you sell? It depends on your costs. So imagine that this is an explanation of our costs. And we also have to consider our revenue when we calculate our profits. So every bag of ice that we sell, we get $1 for that bag. So what that means is if I don't sell any bags of ice, my revenue is 0. My cost, however, is 25 cents. What that means is I have a fixed cost of 25 cents. If I sell one bag, I get $1. If I sell 2 bags, I get $2 of revenue. If I sell 3 bags, I get $3 of revenue, and on down to 6 bags, I get $6 of revenue. So every time I sell another bag, I get another $1 of revenue. What that means is my marginal revenue is $1. Every time I sell another bag of ice, I get $1, which is the same as the price of the product. So that's important to understand. The marginal revenue for perfect competition, the marginal revenue is the same as the price. Now in the last chapter we looked at costs, so you should be able to calculate the marginal cost per unit. Now you'll notice that each line, the increments of output just goes up by 1. So remember, marginal cost is the change in total cost divided by the change in quantity. And I kind of made it easy for you because the change in quantity is just equal to 1 in this case. So the marginal cost of making my first bag of ice, my cost went up 10 cents, 25 cents to 35 cents. Making my second bag of ice, my costs go up by 25 cents because I went from 35 cents to 60 cents. And on down the list. You'll notice marginal cost goes down and it rises. The more that you make, the higher the marginal cost. Now profit is just your total revenue minus your total cost. And we're going to assume, for the sake of simplicity, total cost in this case includes all the explicit and implicit costs of production. So take your revenue and subtract from it your total costs. So notice if you don't sell any bags of ice, you lose 25 cents. You sell your first bag of ice, you start to make some profit. $1 revenue minus 35 cents of cost gives me 65 cents of profit. Now work your way down the rest of the list. So you should discover that profit begins to rise, and then it actually begins to fall again. That 6th bag of ice, the costs were so high, but I only got $6 of revenue, and my profits then declined. They went from $2.50 to $2.30. So the question really is, what output is going to maximize the profits? What output should they sell? If you just look at the profit column, you'll say, well, there's 2 lines that have the same profit of $2.50. They sell 4 bags of ice, they sell 5 bags of ice. How do they maximize their profits? So this is a fundamental rule. This is a fundamental rule that you need to understand. Where to maximize profits. This is important. Where you maximize profits is where your marginal revenue equals your marginal cost. Your marginal revenue equals marginal cost. The reason we have to rely on this rule is because I'm not able in this class to use calculus to prove that marginal revenue equals marginal cost is where you maximize your profits. If you've had calculus, you probably will be able to see this. But in this example, maximizing profits is going to occur with 5 bags of ice. You're going to make $2.50 worth of profit. Now I know you're going to look at it and say, I could make 4 bags of ice and also make $2.50 of profit. But you just have to trust me on this. Unless you know the calculus, you really just have to trust me to rely on this rule. You maximize profit where marginal revenue equals marginal cost. So we'll do another example. I have a product, whatever it is, and it sells for $7 a piece. And I've given you the cost function, and I'm asking, what's the profit maximizing level of output for this firm in perfect competition? So I'd recommend that you pause the video, work your way through the chart, and see if you can identify where that profit maximizing level of output is. So if you've completed the chart, you will realize that your marginal revenue is the same as the price, $7. Every time I sell another unit, I get another $7 of revenue. My marginal costs rise from $2 all the way up to $12. Again, in this case, I just made the math easy. The change in total cost over the change in quantity, I just made my change in quantity equal to 1. So every time you go from one level to the next, I go from 5 to 7, my quantity only changed by 1. So every time I sell another unit or make another unit, my costs go up. It's really just the difference in total cost. And then profit is total revenue minus total cost. And so in this case, you're going to maximize profits with 3 quantity. The quantity is going to equal 3 because that's where marginal revenue equals marginal cost. $7 of revenue equals $7 of cost. Now I also want to examine the graphs. If you remember from the last chapter, the average total cost went down and it went back up again. It had sort of this U shape to it. And marginal cost also goes down and back up again. In this example, where I've set price is equal to marginal revenue, we're going to maximize profits where marginal revenue equals marginal cost. So where marginal revenue and marginal cost intersect each other, at that point is where we've maximized our profits. So now you'll notice in this example, if the price is equal to the minimum of the average total cost, we actually have not made any profit at all. There's just normal profit. Economic profit is 0. But let's imagine that something happens in this market, whatever it is. Let's say it's the market for pumpkin spice lattes, and it's now October. Well, the demand for that product is going to rise. And so go back a couple chapters. What happens when the demand for a product increases? What happens to the equilibrium price? The equilibrium price is going to change. So let's raise the equilibrium price. Let's say now that the price has risen. If you look at this graph, marginal revenue equals marginal cost is at a different quantity. It's now at 9 units, not 8 units. So something happened in the market to raise the price above the minimum of my average total cost. So again, you're going to look where marginal revenue equals marginal cost. That quantity will determine your profit maximizing level. But in this case, we're above the minimum of our average total cost. We're actually making some profit on this product because the price went up. So if I'm going to make 9 units and get $11 of revenue, to make 9 units, the cost is less than $11. So I've actually made some profit. Now let's imagine that something happens in the market and the price goes down. Now notice the costs stay the same, but something happened and the prices went down. Let's say pumpkin spice latte is no longer popular in July and the price of that product falls. Now in this case, what we end up with is, again, a different equilibrium quantity because the marginal revenue crosses marginal cost at a different point than where we were before. So we were up there. As the price falls, our quantity changes. Now you'll notice in this case we're actually losing money because whatever that price is, it doesn't cover the cost to make that number of units. So we're actually losing on this one. Now interestingly, if the prices were to fall to the point of the minimum of your average variable cost, this is a special point. You're losing money. You're losing a lot of money. But in this point, you have what's called a shutdown point. If the price were to go any lower, what that means is you couldn't even afford to cover your fixed cost, much less the variable cost. So you ought to shut down. So for example, if the price falls and a firm can't pay their rent, they might be able to stay in business if they can keep paying all the other bills, the labor, the electricity, the utilities. Maybe they can get the landlord to let them be late 1 month. But if they can't pay the rent and they can't pay the employees and they can't pay the variable costs, they're probably going to shut down. And it may be a permanent shutdown if they don't ever think the price of the product is going to come back up again. If they think they're always going to be here, they'll just permanently shut down. So ultimately, you end up with a case that if the price falls too low, you shut down. If the price is really high, you've made some profit on that. Or if the price is right at the minimum of your average total cost, let me go back to that curve, then you have normal profit. So here's an example of normal profit. Here's an example of economic profit. And here's an example of economic loss. And then we have the shutdown point, if the price falls that low. So now let's look at the long run. Let's imagine that we have one company with one assembly line and another company with another assembly. They have 2 assembly lines. So they have a different cost structure. So marginal revenue equals marginal cost for this average total cost 1 assembly line. Marginal cost is here, marginal revenue crosses it, so they're going to produce this quantity. Again, the price stays the same. They can't control the price. So that firm on ATC 1, they earn normal profit. However, to produce that quantity with 2 assembly lines is even cheaper. So if you had 2 assembly lines, you would actually be making some economic profit if the price were that high. So in this case, firm number 1 is doing okay. They have profit, normal profit. Firm number 2 has some economic profit. Now here's what happens in the marketplace. If you have a firm out there that's selling a product and you realize that firm is making economic profit, so that's above and beyond explicit and implicit costs, they're earning economic profit. Free entry and free exit means other firms might want to enter into this market. So as more firms enter into the market, what happens to the market, the supply and demand? As the number of firms increases, and then you increase the number of suppliers. So the supply increases, the price begins to fall. Now here's the question to consider. As the price begins to fall, do they come in with one assembly line, or they do it the new way with 2 assembly lines? People are going to enter into this market with the latest technology. So they'll come in with ATC2, 2 assembly lines, because that must be how you make profit. So everybody comes in with 2 assembly lines now, and the price ends up falling. And the price ends up falling all the way to the minimum of the long-run average total cost curve. So firm number 1, if this is the price, firm number 1 is going to be losing money. They're going to leave the market. Firm number 2 is going to leave the market because they're losing money. Firm number 3, they're earning normal profit. It makes no sense to have 4 or 5 assembly lines because that's diseconomies of scale, and you would also lose profit. So firm number 3, you would have 3 assembly lines, for example, or whatever function of technology that represents. You would have this average total cost, and your price would fall to this point here, and you would only be earning normal profit. Firms would not enter into the market with old technology. Nobody enters into the field of the profession of farming. Nobody says, I'm going to become a farmer, so let me get a horse and a plow. They always say, I'm going to become a farmer and I'll get the latest, greatest tractor. So you think about this, what happens is the price of the product falls. So in the long run, nobody actually is earning any economic profit. And for many businesses, this is perfectly acceptable. They know that they might have some years of good and some years are bad. Farmers are a really good example of this. Some years are good and some years are bad. Everybody knows that farmers are out there, they make a living. They make a pretty good living sometimes. It's not enough that they're going to become the multi-billionaires of the world, but it's stable and they'll do okay. They like the good years, they work their way through the bad years, and in the long run, it kind of just works out. So in perfect competition, what we have is a market structure with some characteristics that are very specific. Many firms selling an identical product, there's easy entry and exit into this market structure. And if you are in this market structure, then you are what's called a price taker. You take the prices given from the market. You have no control over the price. You're going to maximize your profits where marginal revenue equals marginal cost. If the price of the product, which you have no control over, but if the price of the product is above the minimum of your average total cost, then you're actually earning economic profit. If the price of your product is less than your minimum of your average total cost, then you're losing money. And then we discussed the shutdown point. The shutdown point is that point at the minimum of the average variable cost. You'll stay in business as long as you can meet the minimum of the average variable cost. And then in the long run, firms will enter and leave into this market in such a way that everybody will have the same technology, doing the same thing, and nobody's going to be earning any economic profit. So this is the market structure that has the most competition that's possible. There's not a lot of really good examples of perfect competition. Interestingly, I read an article that talked about hotels being in perfect competition with each other. I would challenge you to think about, is the hotel industry really a perfectly competitive market? We're going to move on from here in the next chapter by discussing the opposite end of the spectrum, in which there's no competition, and that's the market structure of a monopoly. So make sure that with each of these chapters you learn to identify what makes the market structure, where do firms operate in order to maximize their profit,